All right, so what I want to talk about now is chemical reactions and specifically the clues that we have that a chemical reaction has taken place. Now, in the last video, we talked about the fact that chemical reactions consist of reactants, things that are getting combined and mixed up, and we've got products. And so the reality is that there's all these kind of clues that we have, and we're going to come back to this slide in a second, that we have that a reaction has taken place. Now, things like energy change, color change, a gas has been released, precipitate has been formed. We'll talk about that one specifically. Light, sound, odor, temperature change, electricity being released. These are all signs that a chemical reaction has taken place. Now, it's important to know that when we talk about change, we're talking about two different types of change. We're talking about chemical change versus physical change. And so here, let's bring that up full screen so you guys can see that. There we go. Chemical change versus physical change. And in that, with chemical change, that's what's happening in our reaction. We have our reactants that are getting combined and mixed, and we've got our products. Change is taking place. What was one compound has become another compound. That's chemical change. But often, not always, often they're accompanied by physical change. And those are what we talked about with these things here. Energy change, color change, gas. Those are all physical changes that we can actually see. So what I want to do is I want to show you just a couple quick minutes of this classic Bill Nye opener. And I want you to watch for signs that a chemical reaction is taking place. Check this out.
Did you know that everything is made of chemicals? And chemicals can react to form new chemicals. The TV you're watching, the clothes you're wearing, and the food you eat are all chemicals. So is Senor Iguana. Now, sometimes chemicals react with each other to make new chemicals. That's what happens when you see metal rust, or you hear your stomach growl, or maybe you've just seen a candle burning. They're all chemical reactions. Now, chemical reactions happen when the electrons, which are in everything, hook together. Now, here's a chemical you may have heard of. It's called H2O. Do you know what that is? That's right, it's water. Now, water is 2 parts H and 1 part O. Now, look, we're running electricity through the water, and these bubbles are forming. These are two gases. One of them is H, and the other is O. One of them is hydrogen, and the other is oxygen. And look, there's twice as much hydrogen as oxygen. H2O. Isn't that cool? Now, oxygen's in the air we breathe. It's what makes iron rust. It makes our blood turn red. Now, right here, we have a piece of iron, which is steel wool, and we're going to run some electrons through it and make it react with the oxygen in the air. It's pretty dramatic. Yeah, see how it glows orange? Yeah, that's fine. It's glowing pretty good. But over here, we have a plastic chamber that's full of oxygen and another piece of steel wool. Now watch what happens now. Pretty cool. See all the energy that's given off? And the energy's given off because the electrons are recombining with other electrons, making a chemical reaction. So in this reaction, energy's being given off. And in this reaction, we ran energy through the water, and it separated into hydrogen and oxygen. Now, what would happen if we let these two recombine? We should get water again, right? But we should also get a little energy. Well, we can do that because in this balloon, we have hydrogen and oxygen mixed together. And when they recombine, we'll get just a little bit of water vapor, which will end up in the room someplace. And we should get a lot of energy. You ready? 3, 2, 1!
All right, so we'll stop it there. The idea is just the same. So there was a whole bunch of examples of physical changes taking place. Something that we could see, the chemical reaction, when they separated water into oxygen and hydrogen, the two gases, the electrolysis of water. We saw bubbles rising. When he blew into that thing at the beginning, we saw the flame come up. Same thing like we saw the iron burn and combust as electricity was run through it. All of these are physical signs that chemical change is taking place. So I want to see if you can identify some of these reactions that are taking place. This one, I'll give you the first one. This first one is one that we'll see all the time. This is color change and a precipitate forming. And so potassium iodide gets added into lead nitrate, and what we get is this solid that's formed in here. This solid that has now changed colors, and our new thing now has our new substance now has resulted in this precipitate and this color change. And you'll see more of these precipitate examples when we talk about solubility in the next video. But classic example there. Let's go back to the next one here. This is indications of chemical change. This is an acid at the bottom. I think they've got citric acid at the bottom here, and they're going to add baking soda, just like you'd put vinegar and baking soda, same kind of idea. What we're going to get is we're going to get bubbles, and we're going to see a temperature drop. Yes, citric acid and baking soda. We see the bubbles that are happening right there, and we know that a chemical reaction is taking place because of the physical change that we see there. We're also going to see when he goes and shows you, it's kind of tough to tell because they didn't show you the temperature beforehand, but the temperature has changed as well. That's how we know a physical reaction and a chemical reaction has taken place. And then finally, I thought this one was just cool to show you again. We did this one in class when we were upstairs in Paul Elko's room. This one is adding sodium metal to water. And so you can see he's got this nice malleable sodium metal that he's going to take a chunk and he's going to toss it into a thing of water, and you'll see that reaction take place. There's a physical change that accompanies the chemical change. So here it goes in, it starts smoking. There's a good hint that there's a chemical change going on. It catches fire, and then we see a little explosion happen in there. So all of these are really great ways of us sort of saying, hey, there has been a chemical change that's taken place. So that's really all I wanted to show you today. You should be able to predict, or you should be able to say with confidence and certainty that a chemical reaction has taken place based on some of the physical signs that you might see with it. So with that, we're moving on into solubility, which we're going to use to help predict what we form when we have reactions that take place.